All right, here in section 2, it says, complete the proof of the triangle proportionality theorem. Given blank, prove that B over A equals C over D. Triangle proportionality theorem states, if a line parallel to a side of a triangle intersects the other two sides, then it divides them proportionally. Okay, so, and then it asks us to work through this proof. I am actually going to work through this entire problem with y'all. So let's take a look at what this triangle tells me. This kind of goes back to what we just talked about in the last, leading up to 1 to 4. And what we were given was that RM was parallel to PE. So my given is RM, the line, is parallel to PE, the line segment. So let's walk through this proof. It says we have triangle pi and triangle rem with blank parallel to blank. Well, I think that goes back to what we wrote. RM, the line, is parallel to PE, the line segment that was given to us. Our reasoning for this next line is going to say if two parallel lines are cut by a transversal, the corresponding angles are congruent. Well, let's take a look at this. What angles are corresponding in this picture? If these two are parallel, we have IRM. Say I want to start with IRM. Angle IRM. And its corresponding angle would be IPE. What do I know about corresponding angles? Well, right there it says that they're congruent. So we're going to say that these are congruent. Number 3. No reason or statement is given. But I do know that in number 4, I'm trying to prove triangle similarity. So it probably goes back to what we did with question 1, where I then stated, well, angle I is congruent to itself by the reflexive property. So what triangle is similar to pi, and what is the reasoning behind it? Well, pi and rem would be similar, and my reasoning behind that would be two angles from one triangle to the other are congruent. So we do an angle similarity. Next, it says B over B plus A is equal to C over C plus D. The reasoning here is corresponding sides of similar triangles are proportional. Remember, our angles are congruent, our sides are proportional. So these are corresponding sides of similar triangles are proportional, which means their ratios are equal to each other. They did All of number 6 by themselves, they stated both the statement and the reason. They said B times B plus A times C plus D equals over B plus A. Here they did B plus A times C plus D times C over C plus D. And they said multiplication property of equality. So what they did was they multiplied B plus A and C plus D on both sides of the equation. Then they did property of multiplicative identity. So they simplified what they could. We have B plus A was canceled out here. C plus D was canceled out here. So you were left with B, C plus D, and B plus A times C. Here in step 8, it says we're going to be using the distributive property. Well, distributive property, I already know means I'm going to be doing some multiplication to get rid of parentheses, right? So, BC and BD. So, BC plus BD equals. This time we're multiplying in our C. We have BC plus AC. What happened from line 8 to line 9? I no longer have the BC on both sides. So what property was used? Subtraction property. Now, here they said BD equals AC. And in step 10, they divided both sides by AD. Now, they divided both sides by AD, and this is just a division property of equality. I'm dividing by the same thing on both sides. Division property of equality. Okay. Well, what's in common of this BD over AD? The D's. What's in common in the AC over AD? The A's. So I'm left with B over A equals C over D. And this is technically what we call property of multiplicative identity. Just meaning that D divided by D is a identity. So, property of the multiplicative identity. And if you recall, they actually used that same property back in step number 7, where they canceled out the B plus A and the C plus D. Now, was this what we were asked to prove? Yes, we were asked to prove that the B over A proportion was equal to the C over D proportion. On to the next set of questions.